Hi, and this is Intro to Programming for Business Majors, Week 2, Part 2. If you're just starting now, you missed the first part of the lecture, so go back and find Part 1. I'll have that link down below. And let's go ahead and pop into the lecture. Now we're going to start with variables and literals. A variable is a storage name location on a computer's memory. A literal is a value that is written to the code of the program. Programmers determine the number and type of variables in a program will be needed. Let's see example of variable.java. We can pop into that real quick, see if I can find it. All right. So we have it in there. And you can see we have integer value equals 5, and this is the code. We'll come back and look at it. If you want to see the code, we're going to read about it, then we'll come back and explain it. Okay, so let's go back into our lecture. This line is called the variable declaration, the int value. Okay, so that tells us we got a variable, and the variable is going to be an integer, which is a number with no decimals following it. So 5, 10, 20, those types of things. The following line is known as the assignment statement. Value equals 5. So I've declared the variable. It's going to be an integer. Now I'm giving the variable a value. And that value is now stored in memory. So we have this line down here, and this is all from that program. This is all from the variable program to look at. System out print, the value is, this is a string literal. This will be printed as is. It means exactly what it's going to be. And it's print, so, and you notice they put the space, but so we should not, the next line here should print on the same line as this. So this one's now system out print line value. So this is going to print the value. Notice there's no quotation marks. If you actually put the value in quotation marks, it's just going to print the word value. It's not going to print the value of your variable. So the output of this should just be the value is 5. That's what should come out when you run it. An plus operator can be used in two ways. Number one is concatenation operator and as an addition operator. If either side of the plus operator is a string, the result will be a string. This is called concatenation. Okay. So if I put this line here, hello plus world, it's going to print out hello world. If I put the value is plus 5, it's just going to print out the value is 5. The value is the value. The value is new line 5. But so all these things we could try and play with in class, but that's what's going to happen. It's either side of the operator is a string. It's going to concatenate. String Java commands have string literals must be treated with care. A string literal value cannot span lines in Java source file. So concatenation operator can help form complex string literals, meaning, so if you wrote this right here, this is going to fail. This is not going to work. You're going to get errors. So if you want to have multiple lines like that, what you have to do is fix the problem. These lines plus are now plus cause the error. And this will print out one line, and they'll all be on one line together. It can be used for various data types as well. So now we've got 2 strings plus a number. Can be used for format complex strings as well. The following would be printed plus in tabbed format plus, and you'd have next line tab first equals 5 times 6. That's what the star is. We'll get to it. If you see the asterisk, that's multiplication. Put a comma in there. Next line tab second equals 6 plus 4. And the comma, then third equals plus 16 plus 7 dot. So no math will take place here. This will add up 10. This will add 5 times, that'd be 30. But notice the additional operators also needed must be put in parentheses. Okay. Identifiers. The program identifiers are program-defined names for classes, variables, and methods. Identifiers may not be any of the Java reserved keywords. Identifiers must follow the certain rules. Say identifier about variable name. An identifier may only contain letters A through Z, digits 0 through 9, underscores, or the $sign. The first character may not be a digit. Identifiers are case sensitive, so items ordered is not the same as items ordered because the zero or the O is capitalized here. Identifiers cannot include spaces. And again, you cannot use any of the Java reserved keywords here. Variable names should be descriptive. This is a crime I'm guilty of all the time. I get lazy and just type X or Y, but because I'm lazy to type an actual name that means something. But descriptive names, this is good. This is good practice. Descriptive names allow the code to be more readable. Therefore, the code is more maintainable. Which of the following is more descriptive? Double, TR equals this, or sales tax rate. Obviously, the second one. But if you're like me, you're too lazy and you don't type this. And 2 years later, when you're trying to fix your own code, you don't understand what you were doing. So trust me, spend the extra couple seconds to type. Java programs should be self-documenting. Java naming convention. Java variable names should begin with a lowercase letter, then switch to title and case after that. And that's what we call camel case. So you got lowercase, then each word in there is a capital word. Class names should all begin in title case with a big, More Java naming conventions can be found here. And this is just not a requirement. This is just rules of thumb, and it's good programming practice. Some people like this. Other people are underscore people, which is another way you can separate words out. This is just a rule of thumb. Okay. Primitive data types. Primitive data types that are built into the Java language and are not derived from classes. There are 8 primitive data types: a byte, a short, int, a long, float, double, boolean, and char. Numeric types, you have the byte, integers 128 to 127, short 2 bytes, so we're up in 32,000. Integer goes up into over 2 billion. Long is I don't know where we're at here. There's a million, billion, trillion. It's way the hell up there. Floating can have point numbers in the range of accuracy, and you see you can have decimals here with a float. And doubles can have decimals, and it's with 15 digits of accuracy, and the float's got 7. I mean, I'm not sure what you're doing. You need the numbers this big, but nothing I've ever done. So variable declaration will take the following form: data type, variable name. So you byte, inches, short, month, int, speed, long, time, Integer data types, byte, short, int, and long are all integers. They can hold whole numbers. Integer data types cannot hold numbers that have a decimal point. Integers are embedded into the Java source code are called integer literals. Floating point data types that allow for fractional values are called floating point numbers. 1.7 and are floating point numbers. In Java, there are 2 data types that can represent floating numbers. Float, it's called single precision, and double, also called double precision. And that's precision's based on it's got twice the decimal points behind it. And again, it's really into major scientific stuff if you're worried about 15 decimal points behind, Floating point literals, when a floating point number is embedded into Java source code, they're called floating point literals. The default code type for floating point literals is double. Java is a strong type language. It's the example in Sail. Let's go ahead and let's look at the Sail here. All right, it is hard to see. It is definitely, but down here you'd have the results or the price. 1 second. There you go. So that's better. So this is what the results pop out like. So price, the item, tax, and total. So that's what it's doing. So remember, double values are much bigger. A double's an 8-byte versus float 4 bytes, so they don't always compatibly work together. You can get an error trying to force a bigger number in there. But you can force it in there with a float by appending the letter F, either capital or lowercase f to the literal, and then it'll work. Literals cannot contain embedded currency symbols or commas, so this will give you an error for the pay. It just has to be a number. And floating point literals can be represented by scientific notation. So this could be represented through scientific notation. Java uses E notation to represent values in scientific notation. So when you see E4, that means times 10. So this whole part right here, times 10 to the 4th. And if you guys remember scientific notation, it tells you how many decimal points to move it. So I took this 240. If we move 2 decimal points over, I can say it's 2.4791 times 10 to the second. So you know to get the correct number, you just move the decimal twice. In Java, it'll look like this. So it'll say E2. We want to go backwards, we use a negative, and in Java, you'd have a negative E4. And here, 2.9, 9.6. So that's just basic Java scientific notation. And if you work in scientific fields, that could be an issue. Boolean data types. Boolean data types can have 2 possible values, true or false. The value of a Boolean variable may only be copied into a Boolean variable. So it's either true or false, 1 or 0. The character data type provides access to a single character. Character literals are enclosed in single quotation marks. Don't confuse char literals with string literals. Char literals are enclosed in single quotes. String literals are enclosed in double quotes. But a char can only have one value. And again, you see that /n? That is considered one value because that's an escape value. It doesn't look at that as 2 things. In Unicode, internally, characters are stored as numbers. Character data in Java is stored as Unicode characters. A Unicode character can consist of 2 to the 16th individual characters, meaning each character takes up 2 bytes of memory. The first 256 characters in the Unicode character are compatible with the ASCII character set. And ASCII is the American Standard Code for Information Interchange. Basically, ASCII assigns a number to everything. So capital A, instead of guessing, we pull. All right, so this is an ASCII table. Now, the first ones you see with these are like null and start of header. These are actual commands. Everything you see with the multiple things, that's so up to 31. This is all set commands. And you have 20 is a space. Where's that 30? I'm not sure what we got here. And then you've got, as you can see here, I have a capital A at 65. Okay, it is. That's the first thing is ASCII. Okay, so capital A is 65. Lowercase a is way over here, and it's 97. Okay, so that's what it means, and that's what it converts it to a number and then into binary. That's how the computer can figure out which character it is, and that's how it can tell a capital A from a lowercase a. That's it for ASCII, basically. So the Unicode, A is 65, which I just showed you, then B is 66. And this is the binary that creates 65. This is a binary that creates 66. So the way this works is this is 1, this is 2, this is 4, this is 8, this is 16. So you'd add them up. So if I wanted to do, again, 1, 2, 4, if I wanted to have 6, I would have 110 would be my binary for that. Okay. The characters are stored in memory as binary numbers, and then they are decimal values represent these characters, and this is how it's translated out backwards. All right, I will be back for part 3 on this coming up.